Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to explain the working of shock observer and also I am going to show the animation of how the shock observers works. If you are not subscribed, kindly subscribe the Engineering Xplained channel. If you are subscribed, kindly share and comment. Here I am going to take the working details of this shock observers and also we'll see the animation of that shock observer, how those shock observers work. And later, we'll see the what are the different types of the shock observers used in the particularly automobiles and also where the damping is required. Shock observers or dampers dampen vibrations and minimize unnecessary movement, ensuring a stable and smooth ride by converting kinetic energy into heat and dissipating it. Function: dampen vibrations. Shock absorbers are designed to absorb and dampen the compression and rebound motions of the springs and suspension, ensuring a smooth ride. Maintain tire contact by controlling the movement of the springs. Shock absorbers help to ensure that the vehicle tires remain in contact with the road surface, improving control and braking response. Improve stability. By preventing excessive bounce, shock absorbers enhance vehicle stability, especially around corners. How they work? Hydraulic fluid. Shock absorbers typically contain a hydraulic fluid or oil within a cylinder. The hydraulic cylinder is usually used as a shock absorber, and there the arrangement is made in order to dampen the vibrations. Piston movement: as the vehicle encounters bumps or uneven surfaces, shock absorbers compress and extends, causing a piston to move up and down inside the cylinder. Fluid flow and resistance: the movement of the piston forces the fluid through small orifices, tiny holes, in the piston and valves. Thereby, the flow of the fluid will be slowed down, that will be absorb the vibrations. Energy dissipation: this flow of the fluid creates a resistance that dampens the spring motion, converting kinetic energy of the suspension's movement into thermal energy. That is the heat, which is then dissipated to the atmosphere. Holes. Holes within the shock absorber control the flow of the fluid during compression and rebound, allowing for controlled damping of the spring's motion. Compression and rebound. During compression, the piston moves upward, pushing the fluid through valves designed for compression. During rebound, the piston moves downward and the fluid flows through valves designed for a rebound. Types of shock absorbers. There are three types. The first one, hydraulic telescopic. The most common type using a piston rod and a hydraulic fluid to dampen the spring's motion. Here, this is the hydraulic telescopic shock absorber or a damper we can call. It is having the parts upper mount and lower mount. In that it contains a piston and oil will be on both sides of the piston. And here the small holes or orifices, what we can say here we can find. Okay, through that the fluid will be flowing. And this is the reserve cylinder. The outside there is a reserve cylinder and pressure tube inside. Then the base valve to supply the fluid, it will be there. During extension cycle, when this shock absorber is extending, we can see here the fluid from the oil container that will be flows to the this pressure tube, and thereby extension will be taking place. That will be normal way it will be extends. And during the compression, the fluid will be passing through these tiny holes, orifices, and thereby the movement will be slowed down and that will be absorbed. And the absorbed whatever the kinetic energy is there, that will be stored as a heat energy in the fluid or a hydraulic fluid. and that heat what the generated here by receiving the kinetic energy, and that will be dissipated later. Okay, that is will be during the compression, the vibration will be absorbed and the moment will be dampened. The second, gas shocks. These use the compressor gas like nitrogen to further enhance damping and control. Here, the such arrangements are used in the gas shocks. Here, the hydraulic the system is there for the damping first, and later that oil will be flowing to the another chamber where the gas is contains, and further flow of the this oil will be controlled by this gas, and thereby the gas also slows down the moment of the that whatever the shock absorber is there, and thereby it also absorbs the vibrations and the shocks, and by that is the gas shocks usually these are used in the smaller capacity the vehicles. Next type of is the other variants. There are other types of shock absorbers, including active suspension systems that can adjust damping in real time. The active suspension system it will be having. The active suspension system means based on the load, the what will be there on the vehicle, and also the damping force. Based on that, at the real time, the adjustment of the damping and a shock absorbing will be taking place. That is called as a active suspension system. During the real time, it will be adjust all the forces and fluid flow to absorb the shocks or that whatever the movement is there. And here we'll see that first one, the hydraulic type of the shock absorber. The parts what we have seen, the once again we'll see here. The rod seal, here the rod which is connected to both ends. And here the reservoir tube outside, already we have shown. The inner tube where the fluid is flowing. Then piston, rod, the piston. And through the piston, there are the calibrated seams and orifices. These are the calibrated in order to absorb the particular the shock or a moment it will be used. And here there is these are the orifices here also used at the end. And footwall housing, there is a footwall at the end, there is a housing, and through these small orifices the oil flow will be taking place whenever the compression is taking place, and through the small holes the flow of the fluid is slowed down, and thereby that will be absorbs the whatever the moment is there, thereby the shock it will be absorbing, and that is the shock observation will be taking place, and that shock observer whatever the kinetic energy present in that due to motion, that will be converted into heat energy of the fluid. The fluid will be get heated, and later that fluid will be dissipates heat to the outside. Like this, the damping and the shock observation will be taking place by using the hydraulic shock observers. Here, the moment we can see how the shock observation will be taking place. The outside spring will be there, and inside the hydraulic cylinder arrangement, the piston here, and through that the orifices it will be provided, and both side the fluid flow will be there. Here, the fluid we are not seeing, and outside there is a reserve chamber is also there. Okay. The next type, there is a strut type. The shock observer will be there. That will be having the parts upper mount bearing, coil spring, and Jones bumper, and bellows boot, and strut cartridge, bear strut. It will be there. Okay, like that. Here, this will be absorbed this through this bounce jumper and bellows. What are there? By that, the shock observation will be taking place. That is a strut type. The shock observer we can see. Okay, here this is how the shock will be absorbed hereby through the spring and this bellows boot. What are there? By that the shock observation will be taking place, the absorption, and there usually for the small loads this type of the shock observers are used. Thanks for watching. If you like, share, subscribe, and comment. In the further session, I am going to take the industrial shock observers. And industrial shock observers are also having the a very important role in the industries for the machines. Thank you once again.